The total area of a certain continent is approximately 3.8 times 10 to the 16th square inches. Which of the following is closest to the area of the continent in square miles? And then they give you this unit conversion of 1 square mile is approximately 4 times 10 to the 9th square inches. And so this is a really tricky question, I would say. It's more of a trick question than anything else, I would say, because there's nothing hard about it, but sort of they very carefully calculated out very sort of deceptive numbers and answer choices to give you. And so there's a couple of things that are unique about this question that stand out about it. They are asking you to convert from square inches to square miles. And normally when they are asking you to do that, the conversion that they give you is the conversion just from inches to miles. And so in order to make the conversion from square inches to square mile, what you have to do is you have to make your conversion at the point at which those units are measured. In other words, you got to say, in this case, I have a continent that is rectangular in shape and it has some length of X inches and a width of Y inches. So in order to convert it to square miles, normally what you would have to do is you got to convert this your length into X miles. How many miles is this? And then you'd have to convert your width into miles and then recalculate your area in terms of square miles once you've converted your units at that level. Here, the conversion that they give you is the direct conversion from square miles to square inches. I feel like this is all part of sort of the deception, because they're trying to get you to say, oh, that's great, because now that's even easier. I don't have to do any of this. I pretty much just have to plug this number into our conversion. So we got 3.8 times 10 to the 16th square inches. Trying to get the square miles, and we know we have 1 square mile per 4 times 10 to the 9th square inches. And so these guys cancel out and we're left with just square miles, and what we have is 3.8 times 10 to the 16th over 4 times 10 to the 9th, and it seems like we are done. I would guess over 70% of the people who see this problem would get it wrong, including myself. And most of the people who get it wrong would get it wrong without even realizing that they did something wrong. Because normally when they are trying to get you to approximate or estimate something, something like 3.8 can almost always be rounded to 4. And if you did that here, you're going to get an answer choice that's, within 5% or something of the right answer choice. And the problem is, it just happens to be in this case, there's another answer choice that's a little bit closer. And so this question sort of preys on people who are familiar with the Gmat and how loose you can be with your approximations, because this one really, you need to be very precise in your approximation. And so if I was to say 3.8 is about 4, this is 4 times 10 to the 16th over 4 times 10 to the 9th. 4's cancel out, and this just leaves you with 10 to the 7th, or same thing as 1 times 10 to the 7th, which looks to be D. And D would be close, but unfortunately there's an answer choice that's closer. And so how do you know that you have to be more precise in your approximation? You don't necessarily. So you sort of have to either just don't make your decisions based upon what you've seen in the past, it's still true. Even if they're asking you to approximate, the closest approximation that you can have is the precise answer. And that's really sort of what's happening here. Is even better than rounding this to 4 is if you were to just say, well, this is, 3.8 over 4 times 10 to the 16th over 10 to the 9th. That's 3.8 over 4 times 10 to the 7th. And so 3.8 over 4, that's the same as 38 over 40. 38 over 40 is 19 over 20. 10 to the 7th. So if I wanted to convert 19 over 20 to a decimal, easiest way I would say is to get it over 100. So you can multiply by 5 over 5, 95 over 100, so it's 0.95. And so this is 0.95 times 10 to the 7th. Now, another reason is, on approximation questions where you have to be more precise in your approximation, usually the way you can tell is by looking at how close the answer choices are to each other. In this case, it's very hard to tell how close they are to each other by just looking at them, because you have these different powers here. So we got 0.95 times 10 to the 7th, which I don't see as an answer choice, but I do have a couple of answer choices with a 9.5 in them. And so if I want to make this base here a 9.5, that would be, so I'm moving my decimal point here one spot to the right. So in order to balance it out, I got to move this guy one to the left. So 9.5 times 10 to the 6th. That is answer choice C. So tricky question. I feel like another thing that's really tricky question about this is they really don't necessarily say that you have to say which is the closest, but they don't tell you to approximate. They tell you that the conversion that they give you is approximate. And so I feel, based on that, maybe that's, their justification for why you really need to solve this precisely, even though it says approximate, because they're not, even if you solve it precisely, it's still an approximation because you're using their approximate conversion. So, you almost have to get lucky on this question. You have to, for some reason, when you see this, decide not to round up to 4. And if you do that, in this case, it would reward. So that's that one.